Welcome to Smith Weekly Discussions, an occasional program for our readers and listeners of Smith Weekly Research. Please note this program is a private discussion and everything contained herein is for entertainment and educational purposes only. With that, we hope you're in a comfortable position along with your favorite beverage to enjoy the discussion. Before we get into our talk today, we want to say thanks for questions coming from our audience at Smith Weekly, including Dave V, Todd A, Gordon S, and Cindy W. Dr. Elizabeth Ervin is our guest today. Elizabeth is Associate Professor, Civil Engineering at the University of Mississippi. For the past 12 years at the university, Elizabeth has been focused on infrastructure-related issues, including energy infrastructure. Elizabeth, we appreciate you coming on.
Thanks.
So Elizabeth, I wanted to just start, just give us kind of a highlights of your background and the work you do at the university.
Well, I started off as a first-generation college student, and then I got degrees in civil and mechanical engineering. And I also interned in aerospace and nuclear, and then also Department of Transportation. Then I jumped to Pittsburgh and got my PhD up at Carnegie Mellon and was working for the Naval Nuclear Propulsion Program and the Bettis Atomic Power Laboratory for 5 years while I was finishing up that degree. And that was a mechanical engineering degree. And right now in the university, I'm running the multifunctional dynamics lab, which basically balances the combination of civil engineering, mechanical, computer science, and electrical engineering so that we can work on trying to do infrastructure health evaluation in a way other than just a visual inspection.
No, that sounds great, and certainly have some diverse background there, and certainly have spent some time with some of the topics we'll certainly discuss today, including nuclear. I want to know what your thoughts are on the energy mix in the United States. What do you think is working and what isn't working there?
It's a tough question because it's so politicized right now. And I look at things I'm not a domestic or foreign policy expert. I look at things as realistic. What's the technology that's out there? I think it would be fantastic to be able to get the renewables like solar, hydroelectric, biomass, wind, geothermal. I would love for those to be dominant. However, technically at this time, that's not really possible. Not every place has sun all the time. Not every place has geothermal possibilities. There are side effects to all of these. With the hydroelectric, if you dam something, you affect everybody downstream. No way of getting energy is perfect where there isn't some kind of side effect. So to me, the most rational division would be, I would love whatever energy source has the minimum amount of side effects, but then you say, who is that for? Right? So now we're into that political side again. So if you're the person downstream from the dam, then you're the person that cares the most about, are you going to do hydroelectric for me? So if you're the coal miner, you're going to want to have coal be your greatest value. I mean, you want your job. So it's all going to be based upon who you are in the society and which one of these is going to fit. Now, for me personally, and again, talking about me as an academic person looking at it, I know that I would prefer to have the balance between a healthy planet and a healthy economy. Like, how are you going to do that? You can't have all the healthy planet without having some of the health. That would hurt the economy so badly that you would be losing jobs for everything, and then you couldn't afford the equipment to have the healthy planet, which might be the renewables. If you do all the healthy economy, then maybe we go, coal for everything. And then what happens is we end up smoggy. So we give up the healthy planet. So this is a real delicate balance between the two is the way that I kind of think about it.
No, I think it is interesting, and you made a few comments related to hydropower. being originally from Oregon in that area and being involved in the construction industry up there in Oregon, I remember a number of events where we removed and decommissioned some smaller hydroelectric dams in that area. And not only was it a concern with people maybe living downstream of that dam, but also there's been a heavy push, and it still exists today, a heavy push towards, well, the fish need to get above that dam, and so it's been a push from salmon migration and so forth, and so you have those challenges, and then also there's not always a river in every place either that's viable for hydroelectric, and so it has its impacts, and you got to weigh, like you just said, I thought it was well said, you have to weigh those total benefits and the total negatives of whatever source you're talking about, whether it be natural gas or geothermal or coal or whatever it may be. And so I think it's really important that people understand that, and you've really got to understand also, you can't just look at energy and say, well, or look at what the perception is, because the perception doesn't always bring out the economics. And that's also important as well, because without the economics, really, you can kiss the rest of it goodbye. So, if you live in the United States, you're lucky enough to enjoy a superpower that has had a good run. And with that energy infrastructure that's been fantastic. And so you can't get naive about how the economics work. If you take away those economics, your lifestyle, if you live in the United States, could be significantly different. And so it's all of these components that make up this greater piece that exists in the United States. And so I think people often forget that, especially in times of abundance and really easygoing times. And I think that the U.S. has provided that for many, many, many decades. And so I think that's also important that people understand. Now, you mentioned some of these energy sources. Can you kind of expand a little bit on your thoughts about maybe solar and wind, and then also recently with really post the financial crisis in 2008, 2009, there's been quite a heavy duty push in the United States in the shale oil and nat gas. There's been a lot of money thrown at that industry. And what are your thoughts on gas prices and also natural gas being a part of the energy mix? What do you see going on there?
All right. I think it's interesting if what would be your guess at the world renewable use? I would think that there are a lot of countries out there because you were talking about the American value, the American system. I would think there's a lot of countries out there where wind power would be more advantageous than maybe in the U.S., or solar may be more advantageous. But on the planet, 5.6% of the energy, according to the EA Energy and Information people, it says 5.6% of solar, wind, thermal, geothermal, for example, even tidal, all of those, 5.6% internationally, but internally, we're talking about 11%. And the biggest problem with that is that the capital to start these, in order to make, for example, one nuclear power plant of kind of the standard size, you'd have to put solar panels all over, covering the state of Iowa. Now, if we can't get the technology better in the solar panels, then Iowa's gone, right? No, the idea is that some of the research is going to have to be in getting those dams or solar panels or the geothermals into a better technical situation, so those side effects aren't so bad, so that we get them more efficient, so that we can get above those. So there's a lot of research in those areas that really needs to be supported. Now, the shale, what needs to be supported is those side effects as well. And we've all heard about fracking, and we've all heard about the fear of the earthquakes coming. And definitely have done research in earthquake, and I definitely do not want those to start being induced in more locations that are not prepared for them because they've never experienced it. For example, the design codes for everything don't include the possibility for that. It does make me nervous when you say right now natural gas is about 30, about 1/3 or so of our energy production in the U.S. I think that's a great percentage. It has much less greenhouse gas emissions than coal, which is at about the same. And the other 20%, which people might be surprised about, is nuclear. And I always say, can you imagine your electric bill going up 20%? You wouldn't be happy. Well, let's cut out nuclear, and that's how that would work. So the natural gas value and what is keeping all of the fossil fuels and keeping everything going is actually helping out with our gas prices, is helping out with everything, because you think about how much of that used to be coal and how much of that is now more efficient. It's already in a little bit more refined situation. So I think it's fantastic that we got more natural gas because economically it's helped us. But again, what's the balance? Wouldn't you rather have something that was a little less greenhouse gas emissions? I'm sure, again, healthy planet versus healthy economy, right?
Right. I think that right now, if you look at natural gas prices, you've got some challenges with it's priced really for abundance, and people
Right.
think we're not going to run out of it. But the other piece of that is how long does the production prices get financed?
Yeah.
And that's the issue, because when you have natural gas prices very low, and the large bulk of the companies really they better have some other assets along with it as part of really natural gas as a byproduct, because if you had to rely just on natural gas prices alone as a business, you're probably going to be looking to file for bankruptcy, especially because at these prices, there's not a lot of profitability, there's not a lot of margin for error. And so it'll be interesting to see with some of the exportation that's starting to happen, some of the energy issues in Europe with supply from natural gas supply from Russia, Japan starting to do less liquefied LNG import. How the price will respond over the next couple of years, and as you know, just like fuel prices at the pump, once natural gas prices start to rise, it is a substantial cost input for these plants that are producing power from natural gas, and so it'll be interesting to see how that plays out.
Oh, I'm sorry.
Sure.
Could I tell you a little story about Mississippi? And I think all of the folks down here are very aware of it. And that would be the Kemper County project that has been going on. This was supposed to be as part of Obama's climate plan. He said, we're going to have a clean coal plant. And I'm sure you've heard clean coal. It is in air quotes. Get it? Air quotes, I know. But the reason why is because the new technology is supposed to be employed. We've been working on clean coal technologies, and there's still research ongoing. There's some here at the university. And the whole concept is, yes, we can still use the cheap coal, but we can use it in such a way that we're not releasing the fossil fuel byproducts into the environment to cause the greenhouse gases, cause the greenhouse global warming, all of those for climate change. So they funded, supposedly it was supposed to be $2.7 billion to start this plant. It started in 2010 construction. It was supposed to finish in 2014, and every time they had a milestone, they hit some kind of problem. It was either scaling up the clean coal technology, or it was some piece that didn't work, or it was something always coming up, and then they ran out of money, and they were starting to put the money onto the people in the county, and that's not fair. And so it was supposed to finally finish up, and the next thing was 2017, and now it was $7.5 billion. And in 2017, they said, this is not going to work out, and decided to switch to natural gas. So that's my fear, honestly, is that they take these plants and then switch the source of the gassing, which sounds easy from the outside, but from the inside, technically not easy. And then switch to natural gas. Well, what's going to happen when, like as you say, the byproducts start running out?
Right.
And so this natural gas plant that was supposed to be a clean coal plant, now what's it going to change to? Just shut down for $7.5 billion of capital investment. And Southern has taken a pretty good hit for the Southern Energy, has taken a pretty good hit for it.
Wow, I bet the contractor who's in charge of that project, it's Change Order City. I bet they're enjoying that. That's really too bad. What's interesting. Certainly was not aware of that. I appreciate you sharing that. What do you think? Let's talk about wind and solar for a moment. What do you think is wrong with wind and solar that people really haven't yet become to understand?
I think that people don't understand the smart grid. I mean, we love the word smart, right? We love smart infrastructure. We love smart phones. We love smart devices. We love smart everything. But imagine that you need to have a system that understands the demand that's happening at your house for electricity in order to figure out how to send you how much you need. I mean, how many computers would that take? It'd have to connect from your house to where your utility is, to where their source is, to where whoever's monitoring everything is. So, for example, my energy comes through a lot of different sources, but I'm hydroelectric. What happens when we have a drought? Where is that downfall coming from, right? What happens with solar when it's been cloudy for the last 93 days? What happens when there's no wind? Those all happen. The biggest problem with renewables is that somebody is going to have to store the energy when you get excess. And you've heard about being able to sell some of this back to the company. That's great. But this means that somebody has to have battery storage. And somebody has to control when it comes back to you when you need it because you have excess demand. So this kind of a smart grid does not exist. And that's why you hear about the rolling brownouts and things like this when there's extra heat in the large cities. They just run out. I'm sorry, today we don't have enough electricity for everybody. So I think that is going to be such a capital investment that I think it hasn't been addressed directly. And I think everybody's meters are changing, which is good news. But being able to have them all hooked together into a system that would be able to monitor everybody at one time, be able to distribute evenly and equally, to everybody. That's something that I don't know if politically we would ever get done.
So I've got a solution. Everybody's thinking, well, everybody should just, put an Amazon Alexa in their house, and Alexa can listen and connect and tell everybody what's going on in your house, including your energy demand.
You know what? If they pay for it and give me some Wi-Fi, no, I don't want her spying on me.
Yeah, no, it's really comical, some of these things. But tell me about, for a sec. Let's go back to wind and solar for just a moment. And I don't mean to attack wind and solar. I think that it has its place, but at the same time, it has some significant challenges that will not be fixed anytime soon. And what that is tell me, we're kind of really, I guess you could argue that, with some of this stuff's been replaced, and maybe that first generation has come through already and passed through as far as these components. But tell me about
much
wind
more
and solar.
Amazing than they used to be. Yeah.
Right. So tell me about, for a sec, what happens when tell me about the life cycle of solar and wind, And then tell me what happens when these things need to be repaired, replaced, components changed out. Obviously, the battery technology is frequently. Tell me about what's happening with all these solar panels that have been installed over the last, couple decades. Really, tell us what happens when this stuff starts to come off in terms of life cycle, and what are we doing on replacement, and what happens with all the waste of all the old components?
Oh, do you know, I have wondered, for example, the very first Prius that came out, I really wondered, what did they do with all those batteries when they start going bad? What happens when you trade it in? What happens with all those? Batteries are some of the most chemically loaded things in the entire planet, with cathodes and anodes that we know about. It's just two-sided chemicals trading in between. The kinds of chemicals vary based upon, you hear about lithium, you hear about all these other sources. And by the way, amazing battery technology going in. Everybody is working on this problem. Well, I want to make sure somebody's working on what happens as the end product, because I agree with you. I'm worried about where these pieces are going. I'm worried because let's think about the computer components and the leads and the heavy metals that are in there. Those things absolutely used to be in every battery we ever get, and some of them it's still in there. So what are we going to do? Let's make sure it doesn't get into the groundwater. Great. So what do we do with it? I think one of my concerns is specifically having my own cheap solar panel for a little while, is that it got damaged by flying debris. I said, what am I supposed to dispose of it with? So I read through all the paperwork and trying to figure out what was happening. I didn't get any help. So I put it through the university system as e-waste because I didn't know what else to do. So I can tell you from personal experience, I didn't know there wasn't any information in it. I didn't have anything. Most people that have panels, significant panels on their roof, I would say 3 large panels or more, are going to have basically a battery bank that'll kind of rotate in and out. I would say several batteries, depending on what sizes that they are. And think about all the wiring into everything, and the installation is, I believe Obama had in part of his climate plan, he also had that you got a bonus for doing it that helped with the installation cost. But I believe it was kind of standard around $20,000 as a minimum cost for the wiring and getting everything in. So how long does that take to pay back before you have to go buy another battery? And then how do you dispose of that battery? And I don't want to beat up solar either, all right? I would love for it to be able to be easily installed and over every roof and everybody get the benefit of it. But the fact is, somebody's got to wire something in. There is one other way that I have seen solar work that I really think might be a nice approach, which is warming liquids. So, for example, on a warm summer day, for example, in the South, you need, instead of a hot water heater, you might use solar water to warm up your pipes, almost like a steam generator, you know. And in that case, that's great for your battery. You wouldn't need all of that information. You wouldn't need all of that byproduct of battery, but you can only take a shower when the sun's out. So there are a couple issues going on here. Not to say everything else is perfect, just to say that I think the wind byproducts are much less scary to me, but they still have to have the battery to be able to do that. But there's not a glass there. Wind turbines are very typical pieces of equipment. They're standard, fairly easy fixable. There's still a lot of research going on to try to get them smaller, lighter, move faster in smaller winds. Typically, it takes about 3, they're almost at 3, but about 5 miles per hour to get them to start turning because of friction and the weight. And maybe there could be some micro That was one of my ideas, like some microturbines. But the wind has the side effect of noise, and you might have heard of this, that people that live nearby hear a whining sound or something as it's spinning. So that can be a weird side effect too. That can annoy the people nearby. There are a lot of things, but I think the biggest thing that scares me is battery technology and where are the battery byproducts go. And for example, Andrew, you're not supposed to throw your AA batteries in the trash, right?
Well, it depends on where you live.
Yeah, but where are you supposed to put them is the next question. So
right, and that's the whole challenge is with waste from wind and solar, which we have not yet to quantify. I have not seen any work on the quantification of that, and that's the issue.
Now,
It's all
batteries
about
I have.
right. Well, yeah, and the batteries certainly, because we've had those from in our small electronic devices, flashlights, etc., for so many years.
Right.
I think that's starting to happen, and then also in the U.S., there may be some systems set up to take care of this, some management systems for these types of things. Obviously, that has progressed, but it has not progressed yet to the level of what do we do with a whole solar panel? What do we do with wind turbine components? What do we do with the batteries? Which, again, obviously is one of the biggest problems. What happens there? And so
they have every chemical possible,
They certainly have a lot of issues. And the other pieces to that is because that system's not set up, how do you inventory, quantify, and regulate that? And that is another piece that I want to just point out for just a sec. People don't know where this stuff's going. Is it remaining in the U.S.? Is it being shipped off to the lowest bidder? Is it being burnt in another country? What's happening with that? Because no one is keeping track of what's going on with that waste. But yet we know exactly. Let me just go back over to, for a moment, nuclear waste. We know exactly where it is. We know exactly where it's secured. We know that it's quantifiable. We know exactly where it is because it's so important. We don't miss a beat. It's inventoried. We know exactly where it is. We know what it does. Whereas all this other stuff, we don't know where this stuff's going. And it's much, obviously, from a volume standpoint, it's much greater, the waste from batteries, solar, etc. And so that's the challenge that hasn't even been addressed. And the other piece is just obviously the sheer volume and space. You made mention for a sec about the state of Iowa, and how if you included, if you eliminated, again, maybe you can answer this or talk about this a little bit more detail. But just if you covered the state of Iowa in solar panels, well, let's first think about the terrain that you couldn't place the solar panels on, and then let's think about the roads required to get in between them,
right.
And then let's think of all the battery banks and all the other stuff to connect them.
Yeah.
And so I want to ask you about that for a sec. What is your thoughts on how that works when you cover a landscape like this, and you eliminate really ground that could have potentially been used? Obviously in Iowa, we know that there's a good amount of farming ground and so forth that could be used for other things. What do you see on that side?
Well, that was just an analogy. The area of Iowa, of course, I would recommend, just as we've done out in the desert, do the solar farms out there, right? So if we took the maybe feet squared that we would take out of, or acres squared that we would take out of Iowa, and then stuck it out into Death Valley, or stuck it out into the desert where we couldn't grow crops, where we couldn't do all of those things, that solar farm is great area. And but there's two problems there's many problems, but two major problems that I foresee. One, the battery banks are basically battery stations, because they have to be that large. Those enormous places, I can't even imagine, right? It's beyond any comprehension that we'd be able to understand what size batteries that would have to be stored. And you'd have to find someone who built a solar farm to really understand that, in my opinion, because the practicality just hurts. But I think the other thing that I would think, imagine that you need to have the solar panels rotating so that they catch the sun at the best angle all the time. What they used to do is just put some of them in one direction and some of them in the other direction. And then I say now they actually do have some excellent rotating panels. Well, what's the maintenance on a panel that rotates when there's sand blowing around? You know, I have concerns about over time. You know, I'm an infrastructure person. I'm just sitting there thinking about over time, not only are you having to do panel replacements, repairs, what if you have, you know, wire cuts? What if you have that? What if you have sand getting all of those things? So I suspect that the biggest problems out there would not stop if we had enough capital investment, if we had enough research behind it. I do think that the solar farms are going to be an excellent percentage, but I just think we have to get above. How are we going to get power from New Mexico or Arizona out to the people who need it in Boston? I still think that the smart grid is going to be the biggest concern, is how are we going to distribute everything. If we could get the smart grid in such a way that it could distribute it as needed, then you wouldn't have to have such a large battery bank, maybe none at all. And that would reduce a lot of what's going on with the byproducts, which we do not track that I know of.
So I want to just touch on a couple things there. Obviously, this all bodes very well with needing a lot of copper wire. That's going to be a big piece of this. But another piece to it as well is I'm going to go back again to for a moment, because I think this is important for people to understand the scale of the issue. Now, back to Iowa. If we take and cover Iowa, now these solar panels, these things don't work, 90% efficiency. These things are intermittent energy sources.
Intermittent.
So talk to me for a moment just about intermittency of these energy sources, and then also talk to me about heat and how solar panels dislike heat.
One of the things that I'm very particular to let people know is that I really think the day-night idea and the cloudy idea is a difficult thing for people to comprehend. I mean, it sounds simple, right? Yeah, at night you don't get any energy. Sure, but that means that you and your house would have to give up a closet for battery bank, right? Are you willing to give up an extra closet? Most people want more closets, right? And then what's the size of that battery bank for the whole state of Iowa? Where's that going to go? It needs to go in a nearby state. Well, which one? Well, that might go into, because people fear leakage or anything like that, that might go into the NIMBY, not in my backyard kind of category. I don't want to have someone else's batteries in mine. I think over time, the degradation of what happens with a solar panel, I can tell you about mine, it didn't last more than a year, a season. I got through a full season before it was already burnt through. Now you say burnt through, what does that mean? That means that the glass on the front had just basically got so brittle that it cracked. And of course, I don't have high quality or anything I don't have the $20,000 panel. Think about heat expansion and contraction and what that does to something that's like glass that's brittle. And I imagine that that's part of the research that's going on. What's happening over the fatigue of something expanding and contracting, expanding and contracting. And think about that happens every day when the sun goes up and then every day again when the sun goes down, especially if you put this out in the desert, especially if you have a cold night and warm days. There are a lot of concerns mechanically about how one of these solar panels is going to last. And so you want to go spend, I don't know how much a solar farm would be. That's the truth. But I can't imagine it's cheap if your house is $20,000. So if it's $20,000 for every person that lives in Iowa, how's that? And then you say to yourself, holy moly, and then you don't know how long those pieces are going to last. I don't want to make that capital investment unless I'm 100% sure that the technology is there. Now, if you are installing them, for example, on top of a building that already is there and it is a wasted space, then that might be a benefit to be able to do that. And in fact, that's part of an excellent idea besides not just the desert, but if you have a wasted space on top of a building, fill it up with some panels, and that might help you out during the day if you have a large structure, especially if you have a warehouse or something like that. But somebody has to help with this capital investment.
So I want to make a couple comments on that. First of all, in a moment, I want to ask you about the impact on wildlife, specifically from solar in the desert, and then also wind. There's been a significant talk about wind turbines and how that might impact certain birds of importance that may also not already have a great population. I want to ask you about that in a moment, but I want to go back just a moment to the intermittent nature. Imagine for a moment if you have a router in your house that only worked 35% of the time. I mean, how frustrating would it be to hold a discussion like this? How frustrating would that be if your internet was cutting out, really was only maybe 40% efficient, and that's really being generous. I think people need to understand that, and it goes back to the Iowa example again. If you wanted to get back up to an 80 to 90% efficiency in terms of uptime, what would that state actually expand to? Because if really it's not just Iowa anymore, now it's gotten much greater. If you want to have full time or nearest to possible 100% uptime, how does that expand the footprint of wind and solar? And I think that's the other question that really nobody can answer with any intelligence, because obviously we don't know if the winds, the wind might be blowing in Missouri, but how's things in Iowa? Who knows? And so that's the question. And obviously, if even the weathermen on the TV can't really predict the weather that great still, and so that's a little bit of an issue. But tell me, I want to ask you two things. Let's talk about the wildlife impacts on wind, if you've seen or what your take is on that. And then also, my other question to this, I want to move to the economics for a sec. If we went to really a hard charge for wind and solar in the United States as really becoming the larger share of energy mix, how many tens of trillions of dollars are we talking about? And is it really feasible at this point?
All right. So as an academic, first, I support all research into getting renewables up to a 90%. I would love to see that efficiency occur. I would let you know that our vehicle engines aren't even 90%. I haven't seen a 90. If I could get a 90% engine, I would be really a happy person. So if we could get 90% efficiency out of anything, engineers will smile all over the planet, and we will move towards that. Okay? As far as animals, any endangered species should and does immediately stop that project. And I think we all have heard about them in the news in multiple locations all over the planet. Here is healthy planet versus healthy economy again to me. Okay, this might be good for 1,000 people. Does that outweigh this animal's existence if it's an endangered species, right? Is there another way that another environment we could put them in? Is there another? And there's absolutely, we always have folks coming to talk about that. It's a very interesting subject to study, and it's kind of a, political, ethical, moral. It hits all the notes. And what's happening specifically is that where you get a large amount of wind might be in the locations where you have some of the travel. I forget what it's called. I call it the bird highway, where they travel all the way from South America all the way up to north and then travel back down. So you might avoid those areas, but those may be the areas where you have the most wind that you want to put a turbine in. And so absolutely, you're going to see the research studies that are trying to see how can we prevent bird deaths. The other thing is that people may not realize is that wind turbines may be set up in a specific direction, but they could also rotate. And it depends on which kind that you have, and it could rotate with the wind if the wind got strong enough. Or there might even be a motor that is in there that where someone could actually adjust the rotation, or it could adjust when it gets to a certain speed. So there's a lot of things inside of there that if it got a direct hit, you could imagine that rotation could get stuck. You could imagine that something in there would break, and then you wouldn't get maximum efficiency out of the wind turbine to start with.
What would you say on the other piece of that, and that there's some real challenges there. On the other piece, Elizabeth, what is your thought on really, is it really economically feasible at this point in time to just shut off everything else that we have, our base load, and just go to wind and solar? I mean, is it, you hear some people talking about that, which are really out of touch. How many, look, if you had to add it up, would it be 60, 80 trillion dollars? What would it be?
Yes, your other question made me think exactly of the Green New Deal. Now, I haven't officially read the document all the way through, and I don't know that there is one, but it seems like there's some different, but everybody wants to protect the planet. But as I understand it, the Green New Deal says, let's have 100% clean power. That's the first thing. That would be great. What do you call clean power? Does that mean no byproducts ever? Does that mean, I'm expecting that means no greenhouse gases. So that would have to mean that we're in renewables. However, what I don't think people are understanding is that nuclear has no greenhouse gases. So I would say clean power would have to be renewables and nuclear. It couldn't be any oil product. But see, I don't know if that's what they mean. Now, right now we're at about, let's just say 20%. Some people are saying 11% renewables. Some people say, it depends on who you're talking to, which politician, which whatever, which statistical agency. So I'm going to say we're about between 10 and 20%. Give us the benefit of the doubt. If we're 20% right now, and the current growth based upon capital investment into renewable electricity is about 1% per year. That's going to put us at 100% clean power at 2100 AD. I've got a sneaking suspicion that that is not what the Green Deal is thinking. They're thinking that they can do that in 2 years. They're thinking they can do that in 4 years, maybe 8. But we're talking about 2100. So 80 years is a better number because we have to overcome where we are now. And if you increase that capital investment, you'll be able to increase that percentage per year. I would agree with that until we run out of space for solar or run out of dams or we can't build anymore because we're endangering the fish downstream, right? And so I love the idea. I love the sentiment, but I just don't think that it's financially, fiscally reasonable because the economy, if you put enough money in, we couldn't even build everything in 8 years to be able to make this infrastructure work. On top of that, the Green New Deal's second idea is the smart grid, and I totally support that. I don't know how it would happen without. I can't put a number on it, but I know it's in the billions. Okay, that's my minimum. Okay, and I don't know how many. Because, again, imagine that every single person, every single building has to be connected across the country. And maybe that can be done more easily than I'm thinking, but I don't know if the side of my house is helping anything. And maybe they just connect the major things. But still, there's a lot of people working on how we could do a smart grid that would meter everything and automatically distribute. That's the best part, would be to automatically distribute the energy so that you wouldn't have to have all of those nasty battery banks. So those are the first two items in there. And I don't see it feasible because of the amount of capital investment. However, I think it would make a great amount of jobs. Can you imagine how many solar power plants we would have, like people building the equipment. Oh, it would be an amazing number of jobs as long as we don't outsource it, you know?
Yeah, I think you mentioned a number of things there. I think that, that's a whole nother topic. Certainly temporary jobs versus permanent jobs, and really what that looks
Oh,
like in
yeah.
time
Yeah.
frame. But then also, if you think that perhaps if we just take the nuclear power industry and we call the power side of that only, and maybe if you include some of the infrastructure associated, let's call it and this is, I think, conservative, let's call it an 8 trillion with a T dollar industry worldwide. Now, if you were to take it just in the United States alone and convert over to this so-called renewable, although the word renewable in itself for some of these forms of energy, given solar and wind,
Right.
really is, you have to replace it frequently right now, and there's a lot of waste.
Yeah.
I wouldn't call it fully renewable, but regardless of that, if you looked at, let's see how much that might cost if it is a $50 trillion conversion, trillion with a T. How does the Treasury finance that? Will there be anybody to buy the Treasuries, the Treasury bonds when they are issued? Will there be anybody? Will the Treasury print all that money? And with that, you can be rest
Oh,
assured there would be a huge amount of bad investment that occurred simultaneously with that. But how would it get financed? And is it really, in my view, I think it's just absolutely nuts to think that the Treasury would do anything like that, or the taxpayers would go for such a dilution of the currency to be able to do that. And so I think that is a huge problem, and I don't think anybody really wants to put already a bad situation already worse. As it is stands already, the national debt from a federal level is 20 trillion. Good grief! What?
it hurts. Yeah, I know.
So, but look, I want to move on. I want to talk about safe energy sources. I want to get your view on what you see as really kind of the worst energy source from a safety standpoint, and also impact standpoint, and then also maybe give me your thoughts on what you think is really a heavily safe energy source when you weigh the total cost of everything.
So I work on trying to decide if bridges after an event, for example, are safe. And I put safe in quotes because what's the definition? It's levels of safety. It's like, I think it's going to be okay, or I know it's going to collapse, right? Those are the two extremes. It's all about risk management. So safety in the inverse is what risk are you going to be able to handle? The risk management when it comes to all of these energy industries are absolutely different. And are you talking financial risk? Then you have to worry about all the capital because you may not be able to get it started and you probably won't get your treasury money and all that. Now, but I'm talking personally, I look at the technical risk. Technology is going to be the problem. So when I look at oil spills and go, holy mackerel, all it takes is one little valve to break, right? And we can ruin the Gulf. I mean, this is something that's a very big risk. And we've seen it. So there's the truth. What happens with natural gas? They burn it off. What about coal? What's the risk of coal? Well, we kind of know, but then we have the collapses and we have the miners stuck inside of it, or they fumigate because they don't have a good, mine air pocket. We have these awful things that can happen. I think the risk with hydroelectric is once everybody's built their new houses down the stream and then the dam breaks. What if we have, for example, biofuels? I think those are like algae and something like that. I think that doesn't have, as long as we don't create some super algae that overwhelms the entire swamp or something and we lose the Everglades, we should be okay, right? But you never know when you introduce something new. The wind and the solar are risk management is more, in my opinion, of the equipment, So to me, that's a pretty safe sort of energy if we could just get that efficiency up. And then we come back to nuclear power where everybody is so afraid. And being part of the industry that I worked in, I said, oh my gosh. But, I went there. The paychecks are usually a little higher than some other places, kind of like petroleum industry. And I said, why? Because everybody knows if you make a mistake. It is a very intense need for it to be safe. Like petroleum, it is an intense need because if you make a mistake, it could be major. So we all we saw Fukushima. We all heard about Chernobyl. We're all watching that on HBO. This is a 3 Mile Island, all horror stories that have scared everybody everywhere. However, what if I told you that a nuclear power plant is the only power plant that is designed for a 747 to hit it without breaking and causing a meltdown or an explosion? It is designed for earthquake. It is designed for everything. Now, the only catch is this is in the U.S. It has the best design that we can put forward, and they work. It's usually a human error, or it's usually something else that's going on, or a different design somewhere else in the world. I would say if nuclear is done correctly, it's exquisitely safe. But if nuclear is done wrong, it's exquisitely dangerous. It is a risk management issue. That's the worst. Even oil can't top a nuclear disaster. We all know that. And we also know that the oil we can do some things with it. But what do we do when the things that escape have a 10,000-year half-life, right? There's not much that we can do for that.
I think you touched on, we got into some other topics.
Sorry, that's what I think of safe to be, so.
Right. No, absolutely. No, and I appreciate that. When you look at these sources of energy from a deaths to terawatt hour basis, obviously nuclear wins quite handily. And when you obviously also when you include the fact that there's no other energy source that provides for lack of better words, powerful amount of power out of something so small and such a small footprint. It's a huge difference from any other source of power. And when you consider on the back end, you mentioned coal, the mine side going into the plant, the byproducts coming from the plant, the pollution coming from the plant. And if you look at a place like China, obviously with one of the greatest populations in the world, you look at the deaths that come out of that. And not just there, other places too. India, the United States has used coal power for a long time as well. Less today, but still used it for a long time. And so you look at the total deaths, you look at people falling off from accidents, construction accidents, wind turbines, et cetera, solar panels. And obviously that'll still come down. But the problem is what's hurting that statistic from the wind and solar side is, as you said, it's so intermittent that, one person falling off a roof can really impact the statistics. And so it's really starting to build there. So from that standpoint, you also have some of the perceptions, and you mentioned some of the perceptions about nuclear power. But if you cut it out, the other piece also that you mentioned is the most high-level engineering across the board has gone into nuclear power. That's where most of your talent has really been placed. And you got to give the talent that has been around in the industry some real credit for an industry that has, what do we have? 452 worldwide reactors, and a number under construction and so forth. And over that 65 year commercial operating period, let's not even talk about the military operating history with nuclear.
Oh yeah, that's the one I was thinking of.
But let's talk about that for a moment. Give me your thoughts. But you have that kind of history, And then you have, let's count the accidents, and I can do it on less than one hand. And you really look at things like 3 Mile Island, which really is a testament to the safety features of that design, and how it really did quite well, even though people make businesses off of the fear from that event alone. But then you look at a Fukushima, then you look at a Chernobyl, which is also a very interesting case. And then you look also what's happening at Chernobyl today versus what people thought Chernobyl would be for hundreds of years. That's changing quite rapidly, much more than people thought. So give me your thoughts on these accidents, and then also talk a little bit more about really the talent that is here in the nuclear industry that provides probably some of the most robust construction designs ever known to humankind.
So the first thing that you mentioned is a little bit about uranium itself. A small pellet, kind of like a rabbit pellet, it's a bad analogy, but about that much of energy provides about 17,000 cubic feet of natural gases energy, 1,780 pounds of coal, and 149 gallons of oil. And one plant that produces 1,000 megawatts or 1 gigawatt of power uses 5 pounds of uranium each day. It's amazing that the energy density that comes out of a very small piece of energy. And out of that, imagine what are the greenhouse gases that come out of that much coal, 1,780 pounds of coal versus 0 for this. The other thing, some of the accidents, I know they're so scary. We all think of the three-eyed fish on The Simpsons, whose name is Blinky, by the way. A coal-fired plant releases 100 times more radiation than the equivalent nuclear power plant. See, you get radiation every day, and a lot of people are so scared of that thought. You get an X-ray, right? But you get radiation when you fly in a plane. You get radiation all the time. A 3 Mile Island accident reduced 1/6 of the radiation of one chest X-ray. Think about that safety design and that safety feature that prevented the radiation from coming out into the public. And Chernobyl itself, it was the poorest, quickest design that they could have put together. They didn't have backup plans. They basically had one containment. The biggest thing about radiation is that controlling it is hard. So you need to have a containment vessel that holds it all in. So the containment vessel that they had was a bunch of water, and that just didn't work. It got dry. They dropped some material into the water, and they lost all their containment, and there you go. One of the things that we have to think about is always you have something inherently on. You have to burn everything else. You have to, this is something that is always wanting to run. So as a designer, you are having to slow it down all the time. You're having to find a way to put some other chemical around it or put some other material around it to slow it down. And if you don't, then you're going to end up with something that you can't control. So as an engineer, you're the one that has to specifically have the talent, I would say, to know that you're dealing with something that is going to explode on you. And it would be like handling C4 all the time. When everybody thinks about it in the public, they think, oh my God, we're going to die because of the daily radiation, or we're going to die if there's an earthquake. And then the people who are the engineers designing it is like, no, we've already taken care of that. We have thought about that. I think that we're covered with most accidents because we've done accident-based design, which is not required for any building unless you're in a seismic zone. and then it's not done for a 747 hitting it. The other thing would be the talent that started these designs. Now, these designs haven't, the ones that are being built are mostly pressurized water reactors. Some are boiling water reactors. There aren't really new ones going out, right? So, and I hope we'll get a chance to talk about that a little bit. But most of these designs are 1970, 1960 designs, and those guys, and again with the military, and those guys were even earlier. These engineers were amazing, and they already knew that they were having problems. They already knew that they would have to control the uncontrollable to be able to make these things. And so we have today, most of the people that are getting hired in are to maintain those things. And again, infrastructure. How are we going to control these aging plants? How are we going to be able to take care of those? So the talent in initially building it was outstanding. I mean, we've all heard about the Manhattan Project, but that's a whole different focus, you know? That was now, after all of that had occurred, can we use this for domestic by reining in the uncontrollable? And then now we have this talent that need to go out there to maintain, and they have been for all these years maintaining these amazing plants that are producing 20% of our energy, despite not having any increase in the actual number of plants. They often will be able to upgrade the plant or try a little more and get a little more energy out of each one.
A lot of key points. Not sure quite where to start on it, but I want to. The bomb. Is there something with these things? Tell me if it's for humans. When the nuclear bomb was developed, and obviously we know there's a huge difference. We're talking about maybe a 4 to 5% enrichment for a commercial power plant and over 90% enrichment of uranium for a bomb. But the bomb was the first thing, and it was during obviously World War II, and I'm sure there was a lot of work started before that, and there was always a race to get there, and it was really just a matter of who could pour the most money there and who really had the talent to get it done. And obviously the United States was the one who was successful first. But just going back to humans and having such a device that is so unstable, there seems to be a drive by the engineers and the talent behind the project to harness something. And when you take that and you go over to commercial nuclear power, and you have the same type of talent that wants to harness and discover something and use it for good purposes. Obviously, it's the best power source we have by a long shot. Is there really just a desire to does that attract talent in itself, and the push to make something the best it can be? And then when you have the military, especially the U.S., that really adopted it, and Russia as well, back during that time, adopted these basically micro PWRs in their military equipment, like submarines. I think submarines was probably one of the first, and then it got into the battleships and so forth. And the Navy uses it substantially. Tell me about that, and then tell me how it's really any different than someone who designs a 747 aircraft, whether you're talking Airbus or Boeing. Obviously, everybody likes Airbus a little bit better these days, for the moment. But nonetheless, talk about what is the difference between making an automobile safe, making an aircraft be able to fly at the altitude it flies, a commercial aircraft with tons of passengers, fly at the altitude it can fly at. Talk about how those risks of safety exist in automobiles, nuclear power, and airplanes. But yet people are so happy to jump into an automobile every day or jump on an aircraft and take a flight.
Oh my gosh.
But something about a nuclear commercial reactor, they think the bomb, and it's not. We know it isn't. But talk about that, and do you believe that there is some real talent out there that tries to achieve and solve these issues to make them as safe as we possibly can?
Well, engineers work on car wrecks because we've all seen the crash test dummies. So we know that that's part of the purpose of having engineers being in the auto industry, working on the car safety. But I think about the car as a potential every day for you to have the wreck to kill you, right? And that car wreck could kill how many? I don't want to say that because it's in the tens, but how many died at Chernobyl within the first few days because of the radiation that leaked out because of bad design and human error. They didn't have enough safety features. Then they made a mistake, and then that was 56 people. So now the cleanup and the cancers after, that's a different story. All right, so you affected a lot of people. How about Fukushima? I don't know yet, right? But immediately it was firefighters, I believe, and people in the area, but it was less than 10 if I understand. The 747 or whatever airplane, we've been seeing that it could be in the hundreds, right? And we take those all the time. And they are designed for crash, but we also know they're very high in the air. There's a difference. And the small PWRs, pressure water reactors, you think about how much different the material is and the small amount of material that you would have. Well, that's less to get out also. But the difference, like you were mentioning enrichment, that's a really important point because that is something that would kind of do a risk management for me. If I have something that is an ore, that is different than something that has been enriched to the point of the Manhattan Project, right? So what's it radiation that it's giving off is a different kind, it's a different amount, and if I put it in my pocket, it will kill me differently. In fact,
Right.
the ore can stay in your pocket as long as you would like, okay? You might not want to do it 10 years, but in fact, the measurements of millirims, you might get, the average American might get 80 millirims from x-rays. You might get 1, 2, or 3 from some ore that's in your pocket. But if you had something that was a higher level, I would have more fear of that kind of element. So if I have the micro PWR in a smaller, it depends on how much I'm outputting, I might have a higher enrichment in it. So what happens is if you have that higher enrichment, what do the engineers do? We've got to make it even more secure. So that's the thing about the military, folks. Imagine how much they have to secure their micro PWRs, not only because it's whatever's inside of it, but whatever's outside of it, because they're expecting that they could be in a war.
I think it's important to just bring that out. And one of the things that people miss often is, again, and it's a latest thing that happens. We've got cars that are running around on the roads that don't have drivers inside the cab, but yet that's okay. And when it wipes someone out on the
I
405
haven't figured
freeway,
that out yet.
and exactly, that's the whole thing. That's okay. That seems to be widely acceptable. That Google or Tesla, can drive
Yeah,
a vehicle down the road and have an accident on the 405 freeway in Los Angeles, and
exactly.
no big deal. And that's the interesting issue is the perception. And I think also with that is when you have the military leading the charge way back, and then you have what's happened
Mm-hmm.
with, if you look over the history of nuclear power, I think we can all agree that the leap forward till today, the designs are absolutely impressive. And you could also say that certainly with Chernobyl, the government had a heavy hand in the design of their reactors there. They
Yes,
had accidents with their submarines and so forth as well.
yes,
You
they
could
did.
certainly make the case that the United States really had the talent and that maybe there should have been, on the commercial power side, there should have been some collaboration with talking with the talent in Britain and France and the United States back then to make sure that they have a good design.
Yeah.
So I think it's really interesting, but yet people are okay with, remotely controlled cars. We're okay with a natural gas pipeline right of way that happens to pass through a neighborhood. We're okay with that.
Yeah.
It's okay if that explodes and wipes out a couple city blocks. That's okay. And that's what's really interesting about this is people think that a hurricane's coming into Florida and get away from the nuclear plant, it's going to blow up.
The infrastructure. One of the things that when we think of infrastructure, you hear almost every day, "Oh, this house exploded. Oh, this bridge fell down." All of these things are happening around you, and you're not realizing that, because it's happening every day. Something in the U.S. is happening with infrastructure. Either a pipe is exploding or this. And that's why I keep pushing. And it's not necessarily viewed as maintenance. I mean, it's not necessarily viewed highly because it's viewed as maintenance. When it's viewed as maintenance, you don't want to put money in on it. So one of the things is everybody wants a new design or a new something. So there is, as engineers, we want to be on what's new. We're like, dude, Tesla's putting out a new car that nobody's driving. I want to design that. And we have, graduates this year that are going to go work there because that is cool. And I'm like, yeah, but we also have 500 jobs in the South about maintaining the nuclear power plants that we need to have these people hired,
Well, I want to talk about that, Elizabeth. Let's move into that now. Let's talk about the staffing challenges that exist in the nuclear industry, and then also these jobs. I mean, new power plants, depending on where you're talking, China or otherwise, or in the U.S. These are really truly permanent jobs. These are things that you can really spend a lifetime if you wanted to, because of the life cycle of these plants. Talk about the staffing challenges that we have.
The nuclear industry itself has, when I was creating this course, I spoke with Southern Nuclear and Energy. And so I can only speak on behalf of my experience with them in the commercial industry. They were very accommodating and let me know some of the challenges they have. And one of the big ones is retention. We all know an aging workforce. We've got baby boomers that are taking all that talent with those first designs and those first maintenance and those first things, and they're leaving. And if now we're having people come in, new engineers, and we're having a retention problem, there's nobody to take over the transfer of knowledge. And there's nobody to continue the work that's being done. And the retention rate, I'd say, is less than, sometimes some years it's less than 25%. And where are these people going? Well, it's after the first year that they would get trained that they start to get a fear. I mean, the money is good, so they go, hey, I'll buy that car, And then they go, wait, it's a job, like I'm going to have to take care of pipes, or I'm going to have to clean this, or I'm going to have to do this maintenance, or they get scared because every day they got to go get scanned, or there's some reason why in this workforce that the new folks aren't staying. This is a little bit before the millennials. As I was preparing the course, it was fall 2009 that I taught an introduction to nuclear engineering. There was no more nuclear engineering course at Ole Miss. And I was from a grant from the Nuclear Regulatory Commission. I had 18 students that were all, except for 2 undergraduates, so 16 undergraduate, 2 graduate students. And I asked them, what's going on? Tell me why you wouldn't go into nuclear. And they said, because we're scared. I said, what if I told you the salary was 10% more than anywhere else, or 20% more than anywhere else? They said, we think about it. Yeah, money talks. I said, and what about if you went after training and you learned this, this, and this? And they went, ugh. You know, I think maybe they don't know what they're getting into. So the point was that we're going to, some of them said it sounded like I might as well take a plant manager job anywhere that I want to. And sometimes the other student would say, I still remember, he goes, these plants are in the middle of nowhere. And he's not wrong. I mean, so there's few people entering. Then there's few people retaining. And after the course, I did a survey and said, now what do you think about nuclear? Now that you understand the safety, but it took education, a whole semester to do that. And they said, now it's okay. Now I understand it. Now I'd be willing to work in it for the right price. And I was like, what was the right price? I said 20%. They said, yeah. So it just, I think there's the engineers themselves need to be educated. And the other thing they don't know is everybody thinks you have to be a nuclear engineer to be working in a nuclear power plant. I was like,
Right.
no. I mean, there's only, like 20 programs in the U.S. for nuclear engineering? No, 95% of their hires are other kinds of engineers, you know? I was like, you didn't know that? Yeah, I was coming out as a civil and got hired in. Of course, they need civils for everything. They got roads, they got all kinds of structures, they got every kind of possible material you could imagine. So
when you look at the technical universities in the United States, obviously, I think we can probably throw a dart at the ones that are non-technical universities, and probably we know what the sentiment is probably there. But let's talk about the technical universities. What do you think the sentiment is these days in the universities, in the engineering departments about nuclear? What do you think is going on there? And do you see it really improving, or do you see that it's really at a real low?
I have had, and I can speak for a couple of, I've had, there is really no in between that I've seen. I've seen certain faculty I've talked to say it's dead. It's dead. It's a dead industry. Why are you even bothering with it? And then I'll see a whole nother group say, oh, it's strong. It's alive. You know, good. Go work on that. You know, there's nothing in between. It's polar opposites, and I'm nothing I ever think of as polar opposites. I'm kind of always in between somehow, but I understand why people say it's dead. If you want something new design, it's dead. It's been dead since 1970. There are new designs, but nobody's built them. So then, what about maintenance? From that perspective, it's alive. In fact, all of the ways that nuclear power vessels and plants can have issues, right, is, you know, brittle and ductile fracture, fatigue failures. You can have radiation problems. You know, there's radiation makes materials brittle. You know, hot, cold, powers, piping. Oh my gosh, these plants have so much piping. And then the other aspect that people, and I would say academics and technical universities don't recognize, but plants and the government recognizes, is the waste. The waste products are very, very important. And I believe environmental engineering places could, you know, hook up a little bit with chemical engineering and come up with some better solutions if everybody got together. But the waste facilities are currently at each site near the reactors. Now, they are very enriched still, the waste byproducts. So they could be used for other things, but mainly they just sit there in these containment vessels. And that is a whole nother problem that can be addressed with a tackle of engineers and a tackle of politicians to figure out what's going on and where to move things and how to combine, and, you know.
Well, let's talk about that for just a moment. I want to go back just briefly, and I want to ask you about really quickly back to the retention and the workforce. What is a suggestion to the nuclear utilities and the nuclear industry? What do you see as a suggestion that they should really consider to improve that retainment rate and improve new people entering into the new talent entering into the industry? What would you recommend to the utilities and the nuclear power industry?
I think they're doing a great job. I don't know that they can change a public perception. I think that I think they do a very nice job. I don't have any complaints. The Southern Nuclear Energy were very helpful with me. I just would like to see more partnerships like that. I would like to see them reaching out to career fairs, and they came to our career fair, and the university was like, oh, we don't have nuclear, so you don't need to come. I'm like, what? No, they come, So sometimes I think it's the university perception. I think it's the student perception. I think it's the public perception. I don't think that the nuclear power industry can do anything different unless they want to throw a little more money into recruiting, and maybe starting this kind of seminar or starting this kind of course at multiple universities, because I think there needs to be some education of academia to understand that there's a market there, and an education of the students to understand that there's a market there. Because even after
Right.
I did this course, I didn't have a whole lot of support because it came from the Nuclear Regulatory Commission. I didn't have a whole lot of support at this university. They were like, okay, whatever, nuclear's over, or they said that should be in chemical engineering, or we don't have a nuclear engineering department, I mean, that's the truth. So everybody just has to be educated, I think. And then I think people don't realize when I say 20% of your power comes from nuclear, they go, what? Yeah, and they think those cooling towers, the hyperbolic cooling towers, they always think that that's putting out fog. And I said, no, that's just steam. That's heat pollution, okay? That's not carbon, gases. Now, if it's a coal-fired plant, that is smog and carbon gases. It might look similar to you, but it's not.
And so on that topic, I want to ask you this. Going back to the utilities and the nuclear power industry, do you think that there's some stuff that they could do on improving that front of perception? Is there some campaigns? Is there some things that they can do? And if so, what are your thoughts on that? How can they maybe start to break through and really get that message out?
I think they have to, when they try to put a plant in place or try to make changes to a plant. And there hasn't been new ones in so long that's where the disconnect was made. And I don't think there's been a national campaign to be able to do any of that. I think you would have to have a bill to build new plants, to approve to build new plants that would cause a little controversy. And then they would be able to join together in some agency that may already exist for commercial companies, and then mount an educational campaign in the forms of commercials, in the forms of ads, in the forms of pamphlets, those kinds of things. And specifically, I think now, without the bill, they could target universities. I don't understand. I think it could get out through the university with education, because everybody's talking about sustainability. I want people to think that it's not just renewables. They don't realize that the most cost-effective, long-term power source is nuclear energy. And that is extremely sustainable because of the nature of uranium. And I want them to be able to include that in curriculum all over the U.S.
I think that there's a lot more they can do on that front. And looking
Maybe
at the
you have
U.S.,
ideas.
yeah, I think that there should also be, it's difficult. You always got to weigh the economics in it. And in the U.S., it is a place today of really a lot of red tape. And there's some good things about that, and there's also some bad things about that. And I think that if you look at the two projects they have being built out, there's been some tweaks to the design. Obviously, the contractor doing it probably does not have a lot of experience in those design tweaks. It's over budget, change order city from a contractor perspective. And I know there's been a little bit of support from the Department of Energy. I think that one, you have to go back and get back to basics. There is a design that exists that's extremely robust, very, very good system. Sure, you might make some updates and make some simple changes, but overall, the design that exists is really robust already. So if it isn't broke, don't fix it. That kind of scenario. And so I think that's important to look at. But with that, I think that, you mentioned a number of things, meetings, work with the agencies directly. A lot in the universities, there needs to be efforts there. There needs to be efforts online, social media. I think you really need to go after, use all the available vehicles and technology that's available now to really get that message out and really to set the facts straight. And the fact is that at the end of the day, sure, like you said before, no energy source is perfect, but there are some that are near perfection. And the reason nuclear power is near that perfection level is because of the history. People talk, there's a lot of fear about, radiation. Well, last I checked, the sun radiates. We receive that. And one thing I've always been curious about, Elizabeth, is how much radiation do we receive off of our cell phones? What happens there? What's the history? What's the history of cell phone use? How does that work? I mean, do we really know the effects?
If you fly cross country, and this is something that I learned, if you fly cross country, you could have about 4 times an X-ray, 4 times the X-rays that you had in a whole year of just one flight. In fact, if you were sitting outside in the sun, it could be for one day, it could be more than an X-ray. The natural radiation that we get from everything, sun, space, I go around I talk to students and younger kids, and I go around with a Geiger counter, and I always find somebody who goes off because they had a banana that morning, because potassium is radioactive. And they're like, oh, what? I always have a lot of fun with that kind of stuff. But, you have granite countertops. They put that off. And I hate to say radon because that gives you, lung cancer. That's true. But cell phones, the current idea is that they're non-ionizing. So maybe they're okay. How do you like that? Is that a good answer? And the food, a lot of our food is irradiated, and people don't know that because it gives it a lot more time on the shelves, especially the fresh produce. So there are a lot of ways that we can soak in radiation every day. And I think every time I try to talk to somebody about it, and I don't know that I would say that it's a near perfect, because the first impression that you see is the mushroom cloud. As soon as you see the mushroom cloud, you're instantly scared. It's just your first instinct. So that is just a human nature thing that you have to really overcome with education. There's no other option. That emotional response is so much and so strong that, me, I always got called by a company to go work for them. And I was like, what is this stuff? Let me go take a look. And I look up, and the first thing I find is the mushroom cloud. And so if you're trying to overcome that, you have to then go and say, but you have to realize, you get this much per year already, and you get this much per year. And this is all, if you live near the nuclear power plant, you're still not going to get it. you're still not going to get, it's not, where it's contained, it's all contained, you know. And you have to tell people that what's inside of the nuclear power plant does not explode. That's not a mushroom cloud. That's not the same kind of nuclear, you know, content, the enrichment. You try to explain what's inside of there. The way we design it is to go down, not up, you know? And the way that we make sure that whatever is contained is it's got inside of 3 safes, you know? And then they start to go, it's just that emotional response that ruins things, that first mushroom cloud, I think.
And you know, it's interesting. Let's take it down to a level of an automobile. I mean, we've got gas. Let's just take a gasoline automobile. That is taking a fuel, putting it into a combustion engine, and you're really taking that fuel and harnessing it inside of a combustion engine. And but what happens if you take that 5-gallon can of gas and you chuck a match on it in your backyard? It's an uncontrolled response. And I think that people need to understand that a nuclear bomb is an uncontrolled response, and obviously way different in terms of enrichment, whereas a commercial reactor is a controlled response with a very, very low level. It's like taking your gasoline and diluting it with water. It's very, and it's also a controlled response in a commercial nuclear reactor, from again a system that has been devised by arguably some of the best talent that humans have seen. And so it's really, really important to understand those facts.
And imagine that, for example, if the first time that you were in a vehicle, that the very first time you ever drove a vehicle, you crashed. How comfortable are you going to be getting back in it, though? So
that's correct.
Sometimes that emotional fear kind of wins over whatever rationality. So you've got to go on to a campaign. I was going to tell you, when I was teaching this course, right in the middle of the course, one of the students stood up and just said, wait a minute. You're telling me that this nuclear power plant is just a steam power plant? And I said, yes. Wait a minute. So the nuclear only makes the water hot, so we can turn turbines to get energy. And I said, yeah. So wait a minute, that's different than if we use a gas engine to turn the turbines. But that's the same difference. I said, yeah. Because it was just that suddenly it clicked that it's just a different way to turn a turbine so that we get power.
A highly efficient way.
The bottom of a dam, yeah, it's just a different way to turn it.
Yes, yeah, and it's really interesting. Again, the economic benefits from nuclear power, the United States as a base case, is very, very impressive compared to any other form. Now, look, yes, there has been accidents, and those things have happened, and there are challenges. We've got some waste challenges to deal with. But if you go back and you look at wind and solar waste, how big are those challenges? That's when you start to question. That's right. And it's also uncontrolled waste to some degree that we really have not set up a system for tracking, whereas nuclear, the spent fuel rods are calculable. We know exactly where they're at. We know exactly how to protect them. We know how to secure them and so forth. And that's the point. That's the whole key of this people to understand. And so I want to go back. Let's talk about nuclear waste for a sec. So give us a take on what you see. Quantify for us the nuclear waste that exists. Let's use maybe the United States as an example. Quantify for us that, and just kind of for the audience who doesn't understand it, give us kind of an overview of really what the waste is. People think of The Simpsons and maybe a green goo, but really give us what it really is. And tell us about that, and also tell us about really the size. And then obviously we've got a little bit of recycling technology that's going on. So walk us through that and really quantify for us the amount of waste that really is produced compared to this long history of commercial nuclear power.
Well, the amount of waste that the rods themselves last a very long time. I believe it's over 16 months, and they're rotated in and out. And part of the waste that comes out of there, first, know that the humans that are involved, it's mostly mechanized now. So they take a crane, lift them out, and then put them into a beautiful, beautiful pool. we took a field trip, and the second level was a beautiful pool. The second level of containment was a beautiful pool. And the students said, we just want to jump in and swim. And I was like, oh, maybe you don't want to do that. But the basic idea is that you want to cool and you want to contain, and water is an excellent blocker of all this radiation. So it's kind of like things sitting in a pool. And the idea is that every one of these plants across the nation, 100 plus-ish, are going to have a place like this where you're going to store those expended fuel rods. And there's not that many, and it's not that big, even if it's been in a very large place. I don't know that I can quantify it in terms of tons. Maybe you can, but I would say that my concern, and one of the concerns that Nuclear Regulatory Commission has wanted to say, is can we combine them? Because the safety at 104, 100 and something sites versus the safety at one site would be really nice. And that would be a benefit to ensure the safety everywhere and make it temporary. So a lot of them on site are called temporary storage, even though there's not a permanent storage yet. And there was lots of talk and controversy over Yucca Mountain many years ago. And I don't know where that, personally, I don't know where that stands. It kind of seemed to die out. So, yes, all that is governed by agencies. Yes, there's inspectors. Yes, they make sure none of that is getting out. Yes, they can be stored very small and very tightly. In fact, the uranium pellets, very, very tiny, that are being used to put in there. Compared to the, meters cubed, it can't even be compared physically to the amount of greenhouse gases that come out, but that's solid versus gases as well. One of the things that I think is really important is to know that the recycling can be done. So those rods could be taken, or that uranium still has a lot of power in it. And if those things could be taken out, technically the military rods could then be taken down to commercial rods if everything could work magically, and then those commercial rods could be taken down to whatever source is needed for a smaller vessel, example, research reactors, for example, medical research. What about the isotopes that they use as tracers when you get the MRIs or the CAT scans? All those things could be used and created from those rods. And sometimes that's done. And that would prevent the waste and let it go to a lower level, and eventually it gets to a more inert level. However, at this point, that's very, very expensive. The recycling process is pricey. Enrichment is also pricey. So at this point, that's not widely enough done, in my opinion, for us to make use of all the waste. Instead of just storing it at the 100 sites.
Yeah, and there is a number of things that are happening there, and obviously the expense is the biggest inhibitor of that recycle work, and obviously a lot of utilities weigh, well, just store it, and really why do we, the expense of recycling is really, why don't we just go get new fabricated assemblies and go through the fuel cycle and just start over.
Right.
But talk to us about, just briefly about, so you have this spent fuel rod assemblies. Talk to us really how complicated it is for let's say for the security standpoint, talk about how really complicated it is to be able to steal something like this and then use it. Uh, Obviously, you got to have some other technology and infrastructure to be able to use it in a way that could be used
Yeah.
in an intent of a bomb. So I think people really miss that, someone can just show up and rip something off and then all of a sudden it becomes a bomb. It's not like that at all. It's extremely complex and complicated, and you have to be highly sophisticated to be able to do that. Can you just speak to that for a moment?
Um, on my website, I had my students in fall of 2009 write journals about the field trip, because you can't take pictures inside the secure facility. We went to St. Francisville, Louisiana, to Entergy's plant down there. They were excellent hosts for us, and they let us tour the plant and they let us go inside facilities. And so I had the students write each one write a journal about what they saw. You're welcome to read, but they all remarked about security. Did we really have to go through this many times, this many times, this many times? We had to get scanned. They had to check this, And it was, first of all, access to get to the area. Second of all, you got to have a crane because you're not going to get the rods out. And third of all, what can you use it for? You can't up enrich it without having something else. So the equipment is not something that you're going to buy online. It's not an eBay. This isn't an eBay thing, So if somebody says that they've got uranium-235, the enriched kind, the most enriched, dangerous kind, they had to get it from some, military source from somewhere that had enriching processes, that had everything possible, because they didn't get it from the plant next door to you. It's not
Right.
even there to start with. It's already in a lower state than that. There is the concern, people say, of a dirty bomb, but the dirty bomb would not come from these power plants. It would have to come from an even smaller, like local, lower level value than even what this is. I can't even imagine where that would come from in the U.S.
And that's the whole point. I think that, if there are those actors who want something, there's plenty of other countries you could solicit it from, and probably at a less cheaper and less sophisticated price. And so I think that people seem to miss that significantly. And the storage facilities, there is no risk to the person walking through, like on your tour. There is no risk in that form. I want to switch over for a moment. I want to focus just for a second. I want to talk briefly about Fukushima. Now, when Fukushima hit in 2011, kind of take us back there and what went through your mind, and what position do you have regarding nuclear today versus what was maybe your view prior to Fukushima, from a science and safety and economic based view. Tell us about what your thoughts were on Fukushima. What really, in your view, was the breakdown there at Fukushima, and did it change your view on nuclear power?
So I think when it comes to earthquake design, just a little background, forever and a day, earthquake structural design has been controlled by either the San Andreas fault or Tokyo earthquakes or Kobe earthquakes or something in Japan. So those are our two extremes for earthquake design. So when I heard about Fukushima, I said, now here is a place where they designed for earthquakes. It's on an earthquake area. I know Japan is an excellent, very smart, civilized, very well designed, full of engineers country. So I know they did their job. I know it'll be fine. And I believe that it would have been fine, except fire. Fire is not a really good thing when it comes to any structure. And specifically, there's a lot of steel usually in some of these structures, a lot of metals. And so you could have some melting that goes on inside of the plant itself that could cause damage. And so I think, to me, that was my first thought, was I'm more concerned about how long this goes on. I'm not so concerned about the initial whatever happens. I'm more concerned about, the aftermath and what's going on. A tsunami itself, how do you ever know what it's going to do, right? But I would absolutely believe that it's planned. Now, if this was, let's say, a power plant, and I have a list of countries that are looking for some power plants. What if this was on the edge of Myanmar or maybe Indonesia? They've got some engineers, they got great engineers too, but maybe they don't take all the precautions and they're on the edge of the, maybe they don't have as many earthquakes and then they have a sudden tsunami. We know they've had that. There's a couple of, I might have had a different impression from some of the other countries. So then when I start to see what's going on, I'm following it like everybody else. But I'm not as scared, I don't believe. Everybody thinks it's going to, explode. I said, no, the worst thing that happens is that you have a release, or you have a meltdown and you have a release into groundwater. You have some water resources. I mean, it's also a little bit farther away from some civilization. In the end, I think, of course, the media is gonna show it as something huge because it proves the point. And there's always going to keep being these little reminders that the mushroom cloud is real, that radiation is dangerous. But I don't think it was as big that was played up to be, personally. As far as what actually happened, I've seen multiple stories. And that seems weird because, again, what really happens versus what they tell you happens, I'm not quite sure. But my suspicion is that anytime we see a fire in one of these facilities, that's where I'm most concerned. In fact, the lack of water is what's the most concerning for everybody. And that sounds weird because, there was plenty of salt water. Yeah, but you keep all of the water separated in these plants so that you don't cross-contaminate things. So you need to have water inside of the core, for example, to cool it. If you don't have water inside, then it overheats and then starts to want to melt down. So put some salt water in there. It's an emergency. And then you'll be fine. And it was on a coast, and most of them are on a coast, so we were fine. It was just we had a lot of fire going on, so how do we get everything in there?
Highly unfortunate. But again, there's always things that can be improved, and I believe that that is being done in Japan. It's evident that the government there is working towards restarting the reactors. That's happened. That's in progress. I believe we're somewhere around the 10 reactors have been restarted. And in a country like Japan, nuclear power really is the best solution they have. They're not huge. You can't cover the entire island of solar panels and wind. It's not possible. You can't sit there and import LNG. It's way too expensive. It doesn't make sense. They're trying to do some clean coal technologies and so forth. But at the end of the day, the finger is pointed back towards a restart. They've improved significantly. And there'll be a number of reactors that continue to restart. The situation is sad. My understanding was that specifically to Fukushima, there was a disruption in the ability of the folks to get diesel to the backup generators for the cooling. And so once those things did not have any diesel, the backup plant shut off. And of course, the rest of the story. That was my understanding of the situation there. And then also there is some truth behind some of the other plants that were much closer to the epicenter of the quake and really took on other parts of the tsunami, depending on where they were placed in the coves and so forth. If you look at the geographic view there from where the epicenter was, there was a number of plants that operated perfectly fine. They were all shut down at one point due to the order of the government. But there is all these other, I think there was at the time some 42 reactors that were in operation. All the rest were fine. And they all got shut down because of what happened. But there was also a number of accounts of people actually going to these facilities for protection. So I think that speaks a number of other points that nobody wants to talk about. But aside from the larger economic situation and the benefit of nuclear in total, I mean, certainly it's an unfortunate accident and very sad, and I'm sure a number of people will remain to be traumatized that were there, and some of the first responders that I'm sure there are other accidents that also occurred as a
Yeah.
collateral damage to what actually happened. So I want to go back and talk about another subject. What do you see on climate change? What is your view on climate change and some of the viewpoints out there? And what do you think needs to happen going forward with the climate change situation? What's kind of just give us your broad overview of climate change and what do you think is your view on it overall?
Well, it exists, so that's the first thing. Anybody denying that it exists, I'm suspicious. What is causing the climate change, we can disagree on. Even some scientists say they disagree upon. We all know greenhouse gases contribute, but greenhouse gases come from multiple sources, a lot of natural. Yes, we are hurrying forward the death of the earth, if you want to think of it that way. But so is a lot of other things that are natural. The earth goes through cycles. The ice age, for example, where the oceans dropped 10, 20, 30 feet to put all the ice on the surface of the earth. It's part of the nature of our planet, and in geological times, we're trying to think of things as in, well, this year we have Santa Ana winds, and next year we're going to have even harder, or the the hurricane season this year and the hurricane season next year. And I say, yeah, but I think that that those are all, nothing on geological times, like 10,000 years versus 5,000 years is what we're talking about, for geological times. So I think that the climate change folks should really be controlled. That discussion should be controlled by a lot of geology and geologists. I think that they have the understanding of the carbon in the air and the carbon in the atmosphere, and my opinion is a lot ceded to what they say. But personally, I would say yes. I think that one day the Earth will end up looking like Mars, for example. But I can't tell you if it's going to be 2 billion years, or I can't tell if it's going to be 1.9 billion. I can't tell if we get rid of cars. Is it going to be 1 billion, or is it going to be 200, years? These are all like lengths of time. That doesn't mean that we shouldn't minimize. But that also, in my head, says that for climate change, we should minimize without killing our economy. Again, healthy planet versus healthy economy is kind of the way my brain works. So I want to minimize everything I know contributes to climate change, because I know it exists. But I want to do it in such a way that I don't kill everything that is making our economy go.
Right. I think that's a key point. I think that people so often want to throw economics under the bus, but then they fail to realize that really the economics is what got us here in the first place. We're able to address and abate and mitigate climate issues because the country is still powerful and has wealth and has things to be able to do that. Imagine a country, and I can't think of one at the moment, but imagine a country that is not in that situation, a third world country that has no economic availability to mitigate anything in their country related to environment. And so I think people need to keep that in mind. The economics are the driver of everything else we're able to enjoy and repair and fix. And so that's really the key point. Right. I want to move on. Let's talk about nuclear powered growth in emerging economies and other nations, namely places like China, India. The U.S. is doing a deal with India to do work on constructing, I think, some 6 new reactors in India. There's been a really hard drive by India and China to get a lot more nuclear into their mix. Saudi Arabia is looking to partner with somebody, maybe the U.S., China, and Russia, everybody together to do something there in Saudi Arabia. So talk to us about the growth of nuclear globally, and then also tell me your thoughts on the U.S. really maintaining that market share, and as they compete with Russia and China for kind of global nuclear deals.
Yeah, I was looking at the World Nuclear Association information. I have a little bit of fears when it's coming to the Russian involvement. One of the market shares, this could be a way, because we know Russia has lots of experience with nuclear power, and they're not necessarily a friendly country. I'm not quite sure how it's defined, but as of right now, they have 25 countries that are looking at contracts, 25 different countries. And that, while the U.S. has India, as you're saying, think about how much financial benefit they're going to get out of that. With one design, for example, that they could put in all those different places in all those different countries. And also have the ability, one of them, by the way, is Kazakhstan, which is one of the biggest ore producers that's out there. So if they have control of the biggest ore producer, then they have a control of 25 country contracts to be able to build multiple power plants in each country, while we have India, which is not nothing, but come on, this would be a way that Russia can get a foothold into the entire world's politics. Not only that, but have control. If you have control over people's power, couldn't you have control over more than that? But maybe that's just me being paranoid. It's just my brain thinking. First of all, there's a little bit of political concern I have. But then the other thing is financially, we're losing out on, sharing or at least halving some of those contracts. And, maybe if we got 10 of them, how many more jobs would we get and how much more money could we come through that?
There's a lot there, and a discussion on this alone just with the politics and energy, but there's no doubt that energy plays a huge role in how politics and how countries can control other countries. So if you're a country like Russia who really offers that complete package, hey, we'll offer up the operators, we'll finance it, we'll give you the fuel, we own the fuel cycle, we'll provide you all the fuel, we'll give you everything.
Right.
So when they offer a complete package like that, countries tend to bite, but then in return, Russia gets to control a heavy duty portion of that infrastructure. And so that is the whole trick. That is a concern. And from a U.S. citizen standpoint, or a person that lives in the United States, that is a concern looking out there. And obviously, I certainly share that. There are some security issues with that. And then you have China, which is really doing the same. They're integrating a complete package as well, where they want to control their own fuel cycle. They want to be able to own the mines and do all this and really have a complete package. And obviously, we know that the construction globally, when you look at these places like India and China and Russia and other places where they might be building them, Turkey, for example, UAE as well. Obviously, the costs are lower than building in a place like the United States or in Britain. And obviously, we know the French are very efficient at what they do with nuclear power.
Oh, yeah.
And so that's the whole, the cost. Obviously, China is able to roll these out quite well. Obviously, you could always question the quality, but we can certainly all say that I'm sure there's a huge amount. There's no other industry that I can think of that really provides a real huge focus on quality and safety, given what they're dealing with, has a huge amount of potential and power that can both be beneficial and also destructive. So it's really interesting what's happening. You have a place like the U.S. who used to lead in nuclear power, and arguably in some places still is, and there's certainly an attempt by the current administration to start to get back on that global stage where they have a seat at the nuclear energy table and the nuclear table altogether. Where the U.S. you have is falling behind, whereas folks like Russia and China are picking up, and we know Russia likes to control energy. I mean, if you look at Europe and you look at natural gas pipelines and the challenges that are going on there, it's obvious that Russia wants to have an influence in that way, and it absolutely can be used as a political weapon, and really a social weapon and everything else. It could be used in multiple ways, and so I really think it's interesting. But also just the fact that countries like India and China, namely, because they're the largest constructors of new nuclear power infrastructure, it's really impressive what those countries are doing, and yet they have the two largest populations on Earth, and their push is get away from coal and get away from these things that are polluting the air and really killing their people. And for a country of that size, with that population base, I don't see where you can really use another form of energy. You can certainly mix and you can have other parts and pieces, components, but really
Right.
for that size of population and that kind of power demand, the real only answer, all weight, is you got to have nuclear. And I think those two countries have decided that. They figured it out. They're putting their money where their mouth is. It's obvious with the construction that's going on. So I think it's really interesting that where nuclear power might be dying in the United States, it's certainly growing around the world. So the United States can help lead that export of this commercial reactor technology. And then also, you mentioned it, the economics, the talent. Can United States talent go overseas and help these other folks get up to speed? And I think there's a lot of opportunity economically for the United States. And like we just mentioned it, the United States would continue United States influence via energy infrastructure in these other countries, because obviously if the U.S. is going to build plants, there's probably some types of deals that have to do with the fuel cycle and who provides that fuel and who operates and so forth. And so I think it's a key piece that's occurring in the world, where a lot of folks in the United States, they jump on Google and they type in, do nuclear power plants still exist?
Well, I worry a little bit about the when you say about the U.S. sharing things kind of with other countries, because of and it might have been my military time, but I think about the need to know and security issues about information exchange. If China has their own designs, that's awesome. I hope they check them as well as ours, but I hope they're not our designs that went to China, But so I would think that there's probably a lot that will go in there once U.S. decides that they are going to do these contracts. It's still going to take 10 to 20 years to build one of these. So it's a matter of, can we perhaps, even if Russia's in on some of these, perhaps we can, I don't want to say undercut, but offer something that Russia doesn't, which is the more trust politically to be able to get in on it. But again, I'm not the political expert, but that would get us a better market share by saying, hey, now you can say you have, an American pressurized water reactor,
Right. I think that's really key. And when I mentioned sharing, I mean to say that if we don't get out there and lead that charge that we're able to control how that information is shared, how it's built, how it's operated, share that knowledge base.
Right.
Or we don't do it, we sit back and we allow Russia and China to do the sharing. And which would you rather have, sharing that you control, or
Right.
just uncontrolled sharing by other countries? And obviously we know China, India, Japan, Korea, Taiwan. We know a lot of these countries. Korea is certainly making deals. The French are making deals. There are those types of situations that are going on, and so I think that if the United States does not get back into that leadership role of sharing that technology and regulating the technology, I think that it leaves the door open for others to kind of take that position, and some of those others you may not, from a U.S. Political standpoint, you may not want in that chair, and so that's kind of the concern that I have. So and that's speaking from, for us as U.S. citizens, I think it's key to be looking at that security interest, and not allowing, you have to compete on that global stage, and not just at home in the United States, but also on the global stage as well. So I want to talk just a little bit more about another topic, some of the technology that's starting to roll out. You see over in Oregon, you see NuScale Power working their way through the NRC to implement a PWR, small modular reactor design, that right now the economics actually are becoming quite we'll see when they build it, or if they build the first one, but the economics are starting to line up. And then you have Rolls-Royce leading the charge as well towards SMRs. I believe China, I don't know the name of the company, but in China there certainly is some SMR work. We know that Russia has some work on that side, and also in Canada there's an SMR group that's working on small modular reactors up there. So there's really kind of a push towards this, and with that, I just want to highlight again for the audience who isn't really aware of it, you could argue that small modular reactors have really existed for a long time in military applications, specifically with nuclear submarines and so forth. We know that Russia has some floating nuclear reactor icebreaker units and so forth, and these different types of applications that have really already implemented a small scale design. What's your thoughts on this coming out from military and being maybe potentially deployed on a commercial basis in a smaller scale, where you have manufactured facilities that build these things, and you no longer have this really large power plant construction potentially? What do you think of this angle, and do you think it'll catch traction?
Could you imagine your barbecue in the back grill, something that size, being instead the power for your whole house all the time, no problems, no bills, no nothing. And then after a few years, you change it out for a new grill, or you change out some piece of it, and then it starts up again. Wouldn't it be nice? I think it's an awesome dream. The biggest concerns I have, honestly, are control. Who's going to monitor? Who's going to see what level is the uranium of enrichment? Who's going to make sure? I like the economic side is a whole nother story, but again, as I always think, technical and safety and then economic, because technically it has to be, safety, we're hand in hand. And so I want to make sure that the risk is managed. So if it's something you're expecting to go in every backyard in the entire country, then you have a level of risk that's different than some place that maybe goes into every major market for electricity management. Maybe every major city, maybe every city with over 1 million people, maybe every city with over 100,000 people. That's a different level of risk management and a different level of governance. So my first instinct is, I say it's a very excellent idea because it's going to lower everybody's bills and we're all going to be happy after the capital investment part of it. But my concern then backs up to, okay, what about the waste? What about the regulation? What about that? I think that is not there yet, and that will tie everything up for another how many years,
Right. No, I think there's some valid points to what you said there. The concern about, instead of having to secure and take care of, 98 facilities around the United States that might exist now, as far as commercial reactors that are operating. Obviously, there's more than that need secured, but the expansion of that and how that applies. I think that there are some efforts at certainly in the United States, and we'll see what the NRC has to say. but I think there are some efforts in that regard to look at what these SMRs are doing, and obviously there's a huge amount of the safety being addressed, and to what scale are they going to come out at? Obviously the initial design that's out there is a 60 megawatt design that can be hooked in with others to get up to 720, I believe. But also, I think some of the applications outside of mining projects. Obviously, we know that mining is a something that is needed to enjoy modern life. So some of these remote locations that might be able to enjoy power, maybe there's some countries that can't afford a $15 billion nuclear power facility, but maybe can afford a cheaper, smaller version of that. Obviously, a scaled version.
I mean, there's some good uses for having mobile power everywhere. I think we all would love to have our own generator. That's why I say that it'd be fantastic. I just want to make sure that that generator doesn't end up being thrown in something so that it pollutes the groundwater of something, I don't want it tossed away where now for the next half-life of 10,000 years, something is, ruined,
Correct. Absolutely. So I think it'll be interesting to see how those kind of get out there, and if something really happens to go there. I think the idea is certainly interesting, and we know it's coming from a technology that's really been in the military applications for some time, specifically for the U.S. I want to move on to one other subject, or maybe kind of two. I want to talk kind of about just high-level uranium. What's your thoughts on the uranium mining business? And maybe you can share some of that with us. And then what's your thoughts on this current Section 232 uranium petition that's been completed by the Department of Commerce that's sitting on Trump's desk?
One of the concerns is political that people have. I'm not the political type, but unfriendly countries produce about over 50% of what uranium ore comes out of, and that bothers a lot of people, and that's the biggest thing. Now, of course, if you worked in the military and you need some uranium, it's going to be American uranium. Now, the bad news about that is we only have 1% of what is mined used in the U.S. So we import 99%. And this reason that this is because uranium, it's all an economic thing. It was $140 a pound when the U.S. was mining this a whole lot. Now it's $20 a pound. So the commercial industry is really happy. They're like, ooh, let's import it. And so that was kind of a self-fulfilling prophecy. So now being down to one domestic company with about 500 employees and a few sites. I mean, just in 2009, I could tell you a handful of states that were being mined out west, including New Mexico and Colorado and Utah. And now in Nevada, all I can tell you is Utah. So the fact that U.S. production is down and importing is up, that has led to what's on Trump's desk, which is Section 232. And the U.S. producer says, please, can you tariff the other guys so we can get some of the market share? That's about as much as I know about big economics. Woohoo. But there's just too much competition for them. And even Canada is combining with countries from other places in the world, other countries. Again, Kazakhstan is a huge producer now. African mines, which used to be independent, are being bought up. Like whole countries are joining up and independence. So I understand the point of view of the company wanting to stay alive, of course. And I think if we lose our last uranium mine, who's going to be able to provide for the military's uranium needs? However, there's one more factor in here, which is there's a lot stored. And the military seems to have a pretty good percentage stored. We'll never know, but I saw a study a while back that said they have 100% of what they need for 1 year stored. So they have a year backlog. Who knows? And then a lot of the commercial industry has about 250% backlog. So they've got quite a bit of ore, what they needed stored or with subcontracts to be able to do that. So I think that the current mining need is pretty low, is what seems to be. I'm not convinced that we want every mine to go. I think we need that mine, but I think we need it for military purposes perhaps more than commercial purposes, because the free market is kind of balancing it right now. But that doesn't mean that once all these other ones are built and then the market jumps back up to $140, you wouldn't want to have the other mines open and don't let them close. You know, I'm kind of on both sides of everything. So
Well, no, I think you summarized it pretty well, and you said free market, which really caught me here. And I think what's happening in the free market is that the supplies are being depleted. That it's going to start getting uncomfortable for the utilities in the U.S. and Europe to continue to use their inventories. That is starting to dwindle back down to levels that have not been seen for some time, if ever. We know that these reactors and commercial nuclear power utilities like to have security of supply. They like to know that it's readily available. And I think that challenge is really coming to a breaking point soon, probably over the next couple of years, where the mine production, the market price is obviously, because the price is so low, there is an incentive to not really have any interest. There's no attractiveness to mine uranium at such low prices. If you're selling it at $20 in the market and it's taking you $35 to mine it, it doesn't make a lot of sense.
Right.
And so over the last couple of years, if you look at some of you'll find that there is a significant amount of supply that has been cut off because of the low prevailing market price. And as you know, the markets in this type of commodity seem just like anything else. They have supply demand cycles, and we're coming up on a demand side cycle with almost no supply. And so that is starting to become a real issue. And so I think that Section 232 is, I also think that there's a national security aspect, and you touched on it with military need and some other issues. Also, the commercial power reactors in the United States. You had a deal that was done last cycle with Uranium One, and really is just Russian-owned entity now that controls a number of rights in the United States to mine uranium. So there's really lining up to be some real issues where you have an industry, and not just the mining side, but the fuel cycle as well. You know, your conversion, your enrichment.
Yes, enrichment process.
That whole fuel cycle is in jeopardy as well. And so, yeah, you got some jobs. There's certainly some economics. There needs to be there's some jobs at stake, and there's some things that could change there. There are some economics, but you're really talking about that national security standpoint. Do you want to import all of your uranium needs from other countries? And I get the argument that there are some, there's Canada, there's Australia, there are a few friendlies that have it and that mine it, but still, that still does not get past the fact that, do you have the capability yourself to do it? And there is, that's the issue, that's the challenge. And I think that's what will probably, when it does come down, to some degree, national security will weigh in a lot on the issue. And what do you do? And so I think we're at a point in the cycle where you have inventories are decreasing, and there is a need to replenish that inventory. And the question is where and how does that get replenished? And that comes back to the mining side. We all know that uranium is pretty abundant in the world, but to actually get it, refine it, and get it to where it needs to go, that is the lack that we have. That is the challenge that exists. And so obviously the mining side is still the place where most of that comes out, and is still the most economic place to get it. But obviously at $20 or $25 a pound uranium, there's not much incentive in the industry to go out and get it. So I really see that there's a bottleneck coming. I think that from the fact the United States really needs to, as a major nuclear power, needs to maintain the infrastructure and not let that go away. Because as it stands right now, as you said, roughly 50% is coming from those potential so-called hostile nations. And if they decide to turn it off, there's some challenges there. And obviously the lead time required to bring back the infrastructure and build it out and get it back up to capacity to supply the industry is the
Right.
challenge, and you don't really want to be caught with your pants down, so to speak, on this issue. And so that's kind of what I
Well,
see with it. And
it sounds like you support that, Bill.
yeah, I think I don't care if it
Well,
passes or not, because I think what happens, Elizabeth, is even if there is no action, the industry is so critical that it will have to work itself out. The price of $25 will have to
right,
work itself out. And so even if
right,
there is no action, that's fine. It'll still work itself out. And so it's really, it is a nice feature to kind of get the ball going, kind of get a nice shock to the
correct,
industry in the
correct.
United States. But from a global standpoint and from a commodity price standpoint, it's really irrelevant. It would just kind of speed things up perhaps for the U.S., but at the end of the day, you still have a significant supply demand problem coming, and you have utilities that if you go back and you look at the contracting that happened with utilities to get their inventories built up during the last cycle, which really happened kind of between 2004 and 2010, there's a number of years where there is significant volume contracting for uranium. And that is yet to happen again, because there has not been any significant contracting since then. And so you have that new cycle starting to come in. And I think the biggest piece at the end of the day is nobody's interested in digging it, refining it, and sending it off to the conversion facility when you can
Yeah,
only get $25 a pound. It doesn't work. And so when the
right,
economics
no,
doesn't work, you start to build a supply problem. And I think that's starting to come in. And obviously we know last time that one of the key drivers that helped with that, not only was there oversupply already coming because of the uranium price at 140, like you mentioned, that in
right,
itself solved some supply issues. When you have uranium at 140, it kind of helps fulfill that prophecy of, well, there's going to be supply coming in because everybody's going to want to switch and start looking at building uranium mines, because that's where the good price is. And then, of course, the last thing that really wiped it out, as you know, was Fukushima 2011,
mm,
really dampened the spirits of the entire
mm.
sector. And so here we are today. So I think it's really interesting to see this cycle turn and then come back around.
I'm a little concerned about the enriching equipment myself, and I don't hear a lot about it. I don't know where that's taking place. I don't know how old it is. I don't know if that, because that's what we talk about when they talk about Iran. It's like, if they keep enriching, what are they doing with it? You know, if they keep building um, refining and enriching facilities, then what are they doing? I don't know about the U.S.'s ability. I don't really know. So that's, to
And
me, something that's interesting. Maybe you know a little bit more about it, but I could be concerned that that's an obsolete process, obsolete equipment as well.
prices on that side aren't necessarily advantageous either. The infrastructure is wearing down, and there has not been any
Hmm.
capital reinvestment into new infrastructure to keep that capacity. And as a result, it's falling apart. So until there is a reason to input that capital to
Right,
rebuild it, you're right. The fuel cycle capacity in the United States from an infrastructure standpoint is severely lacking as compared to how it was, decades ago. And so that's a challenge. So that's the other question for the U.S. is, do we retain that infrastructure and build it back up and get back up to speed, or do we let other countries do that work for us? And so then you got to
right.
look to places like Canada, Cameco, et cetera.
Hmm.
Some of those
Hmm.
conversions, you got to look over to the French. Uh, and
Hmm.
so, or you got to dig deeper and look to the Russians or the Chinese. And so that's a real challenge. So that's another piece that is lacking, and it certainly is in need of repair. And the only way that gets rebuilt is the utilities got to come out. They got to put out the orders, and obviously the utilities will deal with the conversion and enrichment process and the fabricators. So that means that there needs to be contracts made. They need to recontract, order materials, get the supply contracts for the uranium ore um, coming from the mines, and then obviously they control, the utilities are controlling putting that through the fuel cycle. But the fuel cycle folks, they're not going to be too interested in pulling the trigger on anything until they know they've got those contracts in place. So this 232 could potentially jumpstart that. And so it's essentially, a 25% tariff or a 25% quota, where there's just a allocated amount that says U.S. utilities, you have to buy 25% of your requirements from U.S. domestic sources. And so when that happens, that will certainly change the dynamic. And then that will start to also influx the capital needed to get that 25% production done. So it's essentially a buy American if that's where they go, to where you have to get that 25%. Now, how do we get to that 25%? We've discussed this many times on the show in the past with other guests. That effort is going to require capital and time. And really, to get to that 25% production level, the earliest you could say would probably be 5 years. And capital requirements, really, you'd have capital requirements in the billions to get there. Mm-hmm. And so it's going to take time to ramp up, because right now, as you said, 1% of the requirements or so is actually produced domestically right now, and it's really coming from really one producer, maybe two if you really extend it, but it's really Energy Fuels and UR Energy, and so there's not much going on, and so you really need that kind of kick in the side to get going. But ultimately, if 232 doesn't do anything, then the supply demand dynamics will work themselves out either way, and that bottleneck, if you take a look, is really coming within the next couple of years, in my view, looking at the market and looking at what Cameco and Kazatomprom have done as the market leaders. They've really cut down their production, and they have no intention to return to production until there's that incentive to do so. And so that's kind of the outlook on it.
And I think we have one more problem, being that the U.S. is decommissioning some of their reactors. And I believe by 2025, we're going to lose about 13 reactors, if I counted right.
Yep.
And that means we're going to lose some of our own demand, and that we may not be at 20% anymore. We may go down to 19% before the two you mentioned get back up. So,
right.
And why do you think they're decommissioning? Because they're at the point where they just can't run anymore without not being safe. They've got too many problems, too many issues, too many, and the materials that were made do not last forever with all the electrons and neutrons and all the things bouncing around in there, It is just not a good place to be. So we have to start decommissioning, and at the same time, that's going to lower that uranium demand value as well.
Right, and there's no doubt that some will be decommissioned, and for some, it's certainly a business decision. You have to weigh the cost of trying to relicense, maintain, and upgrade to get that license.
That's true,
to continue
too.
To operate.
Yeah.
And so it's really boils down to some. It'll be a business decision to get rid of and move on, and then some, as we've seen already, there's been a little bit of support for some to continue. There has been some relicensing that's occurred, but you're right, there will be shutdowns. But the nice thing is, at least coming from my desk, is there is plenty of new build construction happening in China and India to keep that demand on a global basis actually increasing. And so that's a good thing. And so the U.S. is in a point where it's got some challenges to figure out what the direction is going to be. And again, if we get rid of the nuclear power in the United States, what really replaces it, and how long does that take, and how much, and that's the real important questions going forward. So Elizabeth, how can the audience reach out to you for more information about your work and your views on the sector?
Oh, they're welcome to straight email me. I'm at eke@olemiss, olemiss.edu, or you can visit my website. It's easier just to search for me. I'm in the Department of Civil Engineering. And it's also helpful if you let me know who you are and what your interest is as well. I'm kind of all over the place. So you just let me know and we'll be happy to talk.
Well, Elizabeth, I really appreciate you coming on to take the extended time with us today and go over these issues. I think that we covered a lot of ground, and I think there was a lot of good points made, and really appreciate your insights into energy and nuclear power and infrastructure in the United States with related to energy. Anything else you'd like to say or mention to the audience?
all opinions are my own and no one else's. How's that?
Well, Elizabeth, it's really been a pleasure, and I really appreciate you taking the time with us today.
All right, I appreciate it too. Thanks, Andrew.